Okay. Trên thôi. Hey. Hey. Okay. Okay, all right. I see most of you have come back. This is Chem 2, Form 6 Chem 2 lesson. So before we start the lesson, I would like to check the attendance. Punozi, are you here? Siêu Trần Hay. And Pun Tihin, are you here? So we have got 3 absent. I'm going to mark the attendance record here. All right. Okay. Now, today I would like to briefly tell the most updated Dsc arrangement as well as our lesson. And leaving behind will be your revision on interchem and enchem, right? Today we will just focus on interchem revision. Now, so you may see this one. I still do some modification, and hopefully I can give it back to you today. So this is the Form 6 Dsc chemistry curriculum the last year, the final year. And it's so lucky that we have finished all the Dsc part. And leaving behind maybe is on the consolidation. You may find that in this year we'll need to have a tough year because we do not have much time to meet with each other, and we do not have any other enough time, for example, do the laboratory section, etc. So, happy birthday, Pango, right? So, this is what I would like to share with you about our schedule. For Chem 2, we will have day 2, day 4, and day 6 having the lesson, which is the same as Chemistry 1. So don't worry too much about the arrangement, okay? Punji, welcome, a long time no see. So you better catch up with what we are having now. So we are now talking about the syllabus, and we have got only a few more months to go. Now, So the day 2, day 4, and day 6, we have got all 3 double lessons. And for Chem Lab schedule, we will find it. You can have a lab section and every day too. But I need to remind to all of you that because as long as there is a face-to-face lesson, we only have about 30 minutes for each lesson, which means 1 hour. And it is quite impossible to make use of that 1 hour only for experiments. So I can do nothing but looking for some after school lab section. So just like what we're having in May, okay, 潘樂之 you're late. Where is pencil? Now, so leaving behind is on the lab schedule, and we will step back to the May arrangement, which is after the lunch, after having the half day school, we will arrange the afternoon section for you to do experiments. Okay, so experiment plays a very important part in chemistry curriculum, even though you know that this year will the Dsc in the Dsc the SB arrangement has been cancelled. You still need to get to know how to do the experiment, because most of the experiment, we can find quite a number of questions asking for the lab skills, asking for the details of the experiment, asking for the procedure, and asking for the safety precautions. All those you better experience it such that you can answer it, instead of just memorizing something that you haven't done it. So this is my intention. I need you guys to remember all those experiments that you have performed before. Now, for day 4, day 6, all those that are in classroom, but as said before, if it's just a 30-minute section, I prefer not to go to the lab, okay? Because it's just a waste of time. And if we have got a 40-minute section, I may consider to have some experiments with you. So for the schedule, the schedule is will not they are just tentative. So what I want to tell you is that first of all, the after school supplementary lessons will be changed to the lab section. For the essay, we will start it this week for the weekly basis, and the quizzes again, which is on the weekly basis, until we go to the uniform test. So I would like to highlight with you on the uniform test. The uniform test arrangement will be we have got a 1.5 hour uniform test, 60 mark questions. All those they are just paper 2. So 30 marks for the industrial chem part, and 30 marks will be N-chem part. In other words, for this paper, you may cover all of those important elements in the in those 2 electives. So this is what I would like to remind all of you is about the uniform test arrangement. So when compared with the real DSC per year, we just have 20 marks for industrial chem, 20 marks for N-chem. And afterwards, you may find leaving behind is on the November and December. Mainly, we focus on doing the past paper with all of you. Because we have just covered the paper 1 already in terms of 2 quite different things, and we need to time. Okay, we need to time all of you to speed up the doing of the past paper. So we will select some DSC past paper of certain year, or maybe you use the mock exam as a start, such that you can do those mock paper together until the mock exam come. Okay, so we have got the mock exam in the mid-January. And what else? Now, this is what I like to mention with you is on the continuous exercise part. We will include the all the marks in terms of homework, the essays. Okay, essays also belong to one of the homework. About the quizzes, the MCs, the quizzes, etc. And even though for the lab, you may have got the lab report, which will be given back to me, and all those I will count it into your 30-mark CA. Remember, I will urge you guys to finish all assessment items, because your report card, which represents the final year of a secondary school life, should probably be shown to the others. So you better score as many marks as possible. This is for term 1. How about final exam? For the final exam, you may have the 120 mark paper 1 and 40 marks for paper 2. This one, I'm sure you have experienced it in Jingong mock exam. Okay, so you may find 120 marks to be finished in 2.55 hours. For paper 2, it is a 40-mark questions, and you have to finish it within an hour. 20 marks will be for in the camp, while for the other 20 marks, it is for NCAM. So theoretically, you can choose NCAM and material chem as well. Okay, so it depends on you. If you want to have a self-study, you may buy the book 7 by yourself and read it. This is mainly covering metals, polymers, nanomaterials, as well as liquid crystals. For those who have got interest in it, you may refer to it. So if you want me to highlight some of the key points, you may, but you better read those content beforehand. Last but not least is on the Dsc arrangement. Okay, I would like to stress it once again that the SBA has been cancelled. This is a very special year, a very special arrangement. Even though you have got the first SBA, which is the titration, the marks will not be submitted to HAEAA. Leaving behind is on the lab reports. Okay, I have kept with you so many lab reports. So once we see each other, we will distribute all those lab reports back, and you better file keep it in a nice manner. Except for your lab, the contents of the lab will also be tested in written. Okay, so you better keep it and file keep it in a nice manner. And what's next is on the proportion of the paper. The 20 marks will be allocated 15 marks to paper 1, and the remaining 5% with about paper 2. What is the hidden message? What is the hidden message? You may find that the paper 1 plays a more important role in determining your final grade in your Dsc exam. Can you get my point? So it is from 60% to 75%. Even though before the inclusion of SBA, you may find it comprises the majority. After that adjustment, you may find that, wow, it is an overwhelming part in your DSE. And later on, it is elective part. It is not just more important, it is much more important. Tell me what you should do to win in this competition. Paper 1, paper 2, of course you need to practice more. And in particular, it is paper 1. Okay? This is what you need to do much for that part. And it's for paper 1, compulsory part. And now remember, each part of it we need to achieve certain level of attainment in each part before you secure a certain level. Now, for example, multiple choice, if you want to score a level 5, what marks should be scored? 陳景希
係咪29、30分
？More than 30, I must tell. It may be more than 30. For example, 32 is safer limit, okay? So for 5-star, 5 double star, you should get nearly perfect. So if you just tell it's just 28 to 29, or maybe you just scored 4. Okay, especially while you see the public having a relatively high score. Okay, you must get a satisfactory performance in MCs. How about structure type questions? If you want to have a level 5, okay, at least you need to score about 70 out of 84 marks. And how about elective part? If you want to have a 5, what should you do? Nearly 28 to 30 marks, right? So each questions you have to score about 14 to 15 marks. Can you get my point? Can you get the whole picture of what is that happening? Okay, so that's why after the paper 2, we have the remaining time I will focus on doing the paper during the lesson. Okay, I will focus on doing the paper during the lesson. So the assumption is that you should memorize all those content well. You should get to know the concepts well. For those who still may have got difficulty in catching up all those, you may find that some of you have found those old boy tutor for help. For some others who really want to have it, you have to let me know. Now, there's no time left. It's now September, so we will just meet you guys for September, October, November, December, and January. Just 4 months only. So time is limited. Okay, get yourself prepared for that. I'm sure you can make it. Any questions? Now, if not, I would like to give you Benzil, are you here?
喺度啦 ，Sir。
Late. Shall I mark it late?
Do it.
Okay, shall I mark it late for that? For that's because you just have more than 5 minutes late. I'll never do it again, please. So for the remaining students, you are going to do the paper 1 practice now. I just want to make sure all of you would know what to do. So it is. I would like to show you this one. Once again, I need to check if I can still send the file here successfully, because in the Chem 1 lesson we cannot. I don't know why. Let's see. Yes, that's right. Successful, right? I just sent out the file. So please download it first. Can you see that? Please download the file.
I can see it. I can see it. It's in the chat room.
You just open your old file first, okay? I just send the file. Okay, you just open your own file and read it, and you use this as a basis to do your work. Now for the others, just like Peng Gaho and Lai Wenjing, I will give you some other exercise. Just wait for me.
Oh my God, it's a virus.
That's enough. Now, Marcus, do you mean that you don't want to open that, right?
No, I opened it and then realized it was a virus.
Jeez. Now, make sure that you have got the two exercise file for. I just sent the two files. I cannot.
Try sending it one at a time.
I don't know. Yeah. I've just sent a file to you guys on 244. Okay, have you all received it? 244. Of course, the answer will be given only when you have finished.
It's the Unit 43 revision questions, right?
Yes.
Yeah, I have it.
Just this.
I have it. Yeah, it's sent.
Yeah.
Yeah.
Yeah. Just open it and then do it. 43. No 44, just 43. 44 is for the other two students, but not you. So first of all, try those. Only the unit for one chapter would already be fine. So, like 43. Okay. Have you got that? Do I need to send it again into WhatsApp group? Zhang Gaowing, you have got it? Yes, what? Yes means you have got it or you want to have it through WhatsApp. You want it? Hey, communication breakdown. I really don't understand what you are going to say. So I will call upon those students and to answer the subpart one by one. According to the list, right? I will call upon each one of you to have attempt of part of it. So shall we take a look on raining again? Raining.
Yo, thunder's been wrecking through my house for the past 10 minutes. It's crazy. Every 30 seconds, you hear a very loud thunder.
So, Marcus, you better not go outside, right? You have got a high risk to be hit. By the lightning, right?
Yes. I have spiky hair.
Now, well, let me see. So we have got each students to try out part of the questions and give me your understanding. It's just a warm up because we haven't touched that topic for long. Before I ask you guys to have a quiz, let's have a warm up. Okay, it's just a warm-up. Take a look at the first question. In the presence of acid, the hydrogen peroxide reacts with iodine in acidic medium to form iodine. The kinetics of a reaction is studied by the method of initial rate. Again, you may see that term, the method of initial rate, right? So the initial concentration of the iodine used, they are the same and in excess. The following results were recorded. Explain the term initial rate. Chen King-Hei. What is meant by the term initial rate?
It is the rate of the reaction when at time t equal to 0.
Time t is equal to 0.
Yes.
What is the rate? What is the rate? We have got so many ways to measure rate, okay? What is that rate? What is meant by the rate as time is equal to 0?
The instantaneous rate of the reaction.
Yes, instantaneous rate. So this is the key point. Instantaneous rate at time t is equal to 0. So this is the something very typical in paper 2 exam. Even though I've got 1 mark, even though I call explain the term, which means definition only, right? Initial rate here comes 2 points altogether in order to score that 1 mark. Can you see that we have got a higher level of requirement to answer the questions? So 2 points altogether in order to score that 1. Suggest a method with justification, the method with the reason to follow the progress of the reaction. Wang Zhenhong. Can you suggest one way to monitor the progress of the reaction? Now, the best way is to read the equation. Wang Zhenhong, are you here? What would you suggest? Zhang Gaowen, you just write down use calorimeter, no marks. Suggest a method. He Jinpan calorimetry, the spelling is wrong, so no marks. What to do with calorimetry? Changing color of the solution, no marks. So what is the color change? Can you see that? I only see those different versions of answers. Use calorimeter, no marks. Calorimetry, no marks because of the spelling is wrong. Because the color intensive solution increased. I know color intensive solution increased, but what is the color of the solution? And Chen King-Hei, the calorimetry to monitor the change in color of the solution, you did not tell what is the color change, no marks. Colorless to brown. The fragmented, the answer, score no marks. Chen King-Hei color intensity due to the change in concentration of iodine. You just tell me the change in concentration of iodine, but you didn't tell anything about the color change, no marks. Chen Hou-Hei, color intensity of brown color. You did not tell me anything about the change, no marks. He Jinpan, brown color, no change, no marks. Come on. So far, no one can tell the complete answer.
We can use a colorimetry as the brown iodine is the only colored species in the reaction, and the color of the entire reaction mixture changes from colorless to brown as the reaction progresses.
Now, first of all, the key point, during the progress of the reaction, there is a change of color from colorless to brown. And second, you have to relate the chemical, which is color, which is, what is that? It's iodine. So you're going to measure the increase in the color intensity of the what solution? The brown solution. Finally, you may see the solution becomes brown by measuring the absorbance of a solution mixture using colorimeter. Can you get my point? So first of all, if you write down the method, you may use the term colorimetry. Okay, or you use the colorimeter to do something, right? Use a colorimeter to measure the absorbance of the brown of the solution mixture as you may see, there is a color change during the progress of the reaction. The color intensity of brown solution increases due to the formation of brown iodine. Okay, so you have to tell me the following. First of all, what is the instrument? It is colorimeter. If you want to tell me the method is colorimetry, so what is the use? It is used to measure the change in absorbance of the solution mixture over time. The change in this absorbance, a change. Why? Because of during the progress of a reaction, the color change of the solution is from colorless to brown. Okay, so you are going to measure indirectly the concentration of iodine over time by measuring its color intensity of the brown solution. Okay, how can we relate the concentration of iodine to the color? It is something related to Beer's law. Do you still remember? It is something about the Beer's law, okay? Absorbance is directly proportional to the concentration of iodine solution. So this is a crossover of InduChem and NChem. C part. So this justification part, you need to tell me there is a change in the color of the solution mixture. You need to monitor the progress. Okay, is that clear? After Wang Junho, here comes Choi Zhongsha. C. With reference to the data, suggest the order of reaction with respect to hydrogen peroxide. Choi Zhongsha, are you here? Yep. So can you see the word with reference to the data? So you are going to give me which data should be considered. Check the table here. Which sets of data should be compared in order to get to know the order of reaction with respect to hydrogen peroxide. So this one should be changed, right? And so this one, you have to keep it the same, right? So yes, that's right. Trial 1 and 2. This one the same. This one times 3. And what will be changed in rate times 3. Okay? So deduce the order. Suggest the order you need to give me with reference to data. So the whole thing it is a deduction exercise. You have to tell me comparing the trial 1 and 2, the hydrogen ion remains the same. So the concentration of H2O2 is 3 times higher. That will make the rate is increased by 3 times. Okay? Therefore what? The order of reaction with respect to H2O2 is 1. Why? So you may have got this information, right? So what is the hidden message? This one relates to the fact that rate and H2O2, we have got the relationship. So what is the relationship? Something about mathematics. Marcus, if you are asked to put a relationship between rate and concentration of H2O2, what is that?
Directly proportional.
Yeah, directly proportional. Remember, how about this one? Proportional. Can I write down just proportional to?
No.
Is it correct? So what is the difference between directly proportional and proportional? Don't tell me we have got one more word. So what's the difference? In mathematics, what is meant by partial origin? I did not have any graphical means to tell. So what is meant by partial origin? I do not have a graph. So what is the mean by directly proportional and proportional? So remember that two terms is different.
It can be inversely proportional as well, right? So we have to use directly proportional in order to state
somebody
something
would
like
think that proportional
no.
Can be directly or inverse. What else? Now proportional, if you just merely say it proportional, we'll usually say it as a linear relationship, right? That linear relationship, they may have added with a constant. So that's why by writing down proportional to or directly proportional to, it makes the difference between that two equations. Y is equal to kx and y is equal to kx plus c. Okay, while c is a non-zero number. So if c is 0, it is directly proportional. Okay, y is directly proportional to x. Okay, it is different. Is that two terms is different. But for you have got a constant here, right? So we cannot tell it is directly proportional because we leaving behind we have got some other factors added extra. So we can only say it is a linear relation or maybe proportional. They are in proportion. Okay, so this is something more about mathematics. Order of reaction with respect to H2O2 is 1. So you may, if you want to make a perfect answer, you may write down this, and drop to this. If you still confused about directly proportional to, you merely write down that signal, that symbol, then you can tell it's directly proportional. If you insist on writing English, you have to write it directly proportional. So is that clear? So this part, you need to be very aware of this. Now what I'm now going to tell is about this one. Kx equals y. It's different. So you see that? Now D. Zhang Quan Wei. if the rate equation for the reaction is rate is blah blah blah, what are the rate, what are the values of x and y respectively? So you do it similarly, right? Because for the previous part, you may know this one is first order reaction, right? With respect to H2O2. So this is one. How about hydrogen ion? It's also one. Agree? What is the evidence? How you know that x is equal to 1, y is equal to 1? Y is equal to 1.
When compared trial 1 and 3.
Trial 1 and 3. 1 and 3, is it? You keep the H2O2 concentration the same, but you just change the concentration of hydrogen ion. So what's the change? You double the concentration of the hydrogen ions. How about the rate?
Also double too. Double.
It's also double. So you may find that they are in direct proportion. The rate and the concentration of hydrogen ions, they are in direct proportion. So we call that first order reaction with respect to hydrogen ion. Okay, so the way to check is on the trial 1 and 3. So you may find the rate, it is in direct proportion to the concentration of hydrogen ion. So you may find it's first order. Because of that, you may know the units will be changed accordingly. So what is that unit? Because it's quite strange to ask for X, Y, Z. In reality, I will ask you guys what is the unit of rate unit is that. Okay, so tell me what that is. So what is the unit of the rate constant for this rate equation? So what's the rate equation? Rate is equal to K times H2O2 concentration to the power 1 . So easily seen that you are not following us. And the hydrogen ion concentration. So what is the unit of the rate constant? dm cube per mole per second. Your unit is wrong. It's small letter d. This one. Correct? Agree? Tengking, you just suggest there should be mole square dm or mole per square dm6 per second. How you check it correctly or not is to check the unit respectively. Rate, what is the unit for rate? Mole per dm cube per second. How about molarity? It is mole per dm cube. Similarly for hydrogen molarity, it's mole per dm cube. So you are going to keep track of all those units to come up with this. Do you understand, Thomas? Question 2. Any questions so far for the unit? So you've asked to find out the correct the exact value. Then you may need to substitute the data into it and come up with the unit. What don't you get? 張家榮 You're going to cross those units, right? Cross out those units until you get what is the rate constant. So what is rate constant? Rate constant is K in this question. Refers to the K. You're going to ask for the value. So what you are going to do is to relate that unit. It really depends on the overall order of the reaction. The overall order is 2. Okay, so you are going to times per mole, dm cube, and per second until you get the rate correct unit. The rate will have got the correct unit, mole per dm cube per second, which tells you something about the change in concentration of something over time. Okay, so that's why the unit of rate is mole per dm cube per second. So which means that the one I write in blue, mole per dm cube per second, mole per dm cube, for molarity, all those, they are fixed. Okay? It's an absolute answer, no other answer. So leaving behind is on the one I just put a rectangle here. That unit will be adjusted depending on how many chemicals are there on the right hand side, and also their corresponding indices, right? In short, in chemistry, we call it order until we get dm cube per mole per second. Do you understand, Zheng Gaowing? Just put that 2 into the molarity into the left hand side, right? You cross out those units, and leaving behind is dm cube per mole per second until you got K. Just cross out those units. Number 2. Oh, here comes Zheng Gaowing. Your turn. Pretending not knowing anything that you need to answer, you still have to answer. Question 2. A bromoalkane has the molecular formula C4H9Br. The equation which shows the hydrolysis, you're going to study the kinetics about hydrolysis reaction to form alcohol, while bromide ion is a leaving group, right? So rate of the reaction investigate. I will investigate large excess of bromoalkanes with sodium hydroxide solution and measuring the time taken for the all hydroxide ions to be used up. So that's why we have got the time here. And I use the time data to change it to initial rate. So you listed will be the data. The question comes, explain why the time for all hydroxide ion use up can be indicated by the phenolphthalein indicator. Oh, so you are going to use phenolphthalein as an indication of the certain stage, certain observable stage has formed. So tell me. How and why? When? You just say that the phenolphthalein indicator changes color from colorless to pink. When? When would it happen? penalty, you just write down the first half is all right, is okay, but the second half is not okay because you need to tell me change in color when I use phenolphthalein. You want to relate to the change in pH, but you fail to relate to the color change. Okay, change. So again, student, hey, you did not tell me anything about the relationship to the color change. So 2 points altogether to score that 1 mark. So what is that? First of all, you are going to tell me that when all hydroxide ions are used up, right, something will happen. The pH of a solution drops to a value such that what? Phenolphthalein it will changes its color from what? From what to what? I try to see your answer, right? Zhang Gaowing, you just write down from colorless to pink. But the others would suggest it from pink to colorless. Which one is correct? pH will drop. It will be approaching near to the red to colors, red to pink. So go back to the point. All the hydroxide ions are used up. So is it still? Of course, I would not argue with you. You can make it red, but it is a very beginning of the reaction. So Zhang Gaowing, you just wait until pink and you just stop counting the time, right? So which pink will make you have a stop? Dark pink, pale pink, or medium pink? How would you judge? Black pink, okay? It's not pink at all. Can you get my point? So approaching the observable stage can occur. You are going to relate the color as from pink to colorless because it is the most easily observable. Right? Can you get my point? Zhang Gaowing, do you understand? Red to colorless, is it possible? Again, if I write down red to colorless, it just tells you that is the instant change, right? So what would be the timer to stop? You may find the obvious color change. So what is set as the obvious? It is the color before colorless, which is pink but not red. Can you get my point? Which means altogether it should be red and then turn to the red, it becomes paler and then turn to pink, and finally all in a sudden the pink turn to colors. You have to press the stopper, right? The timer will stop, so it is pink to colors instead of red to colorless. If you write down red to colorless, which means that you have to wait for 10, 30, or maybe 1 minute red color solution, it will suddenly turn to colorless. Is it? Does it reflect the reality? Do you understand? Do you understand the difference between a red to colorless and a pink to colorless? Explain why a large excess of bromoalkane was used. Just write down in large excess, right? This part of some terms that I'm using. A large excess of bromoalkane, it was used.乜要啦？
唔識做啊，市場唔識做。
咁就得㗎啦，氮廢就得㗎啦，而家嚇。To allow the hydroxide to be reacted, you may use it to answer why I use excess bromoalkane. But the point is on the word large excess. Can you get my point? 張家榮 answer, you just tell me why you use excess bromoalkane, but you cannot explain why it should be large excess. Can you see the difference between large excess and excess? Can you get my point? So if you write down just excess, you are going to ensure all hydroxide ions, they are used up. But once I write down in large excess, it means something different. The response time will be sharper. So it means pivot. To ensure bromoalkane does not affect the result. What does it mean by bromoalkane doesn't affect the result? What physical quantities of bromoalkane are you going to talk? Or you just tell me the chemical itself would affect the result. Of course, bromoalkane being a reactant would affect the result. To allow the only change in concentration of hydroxide is the only factor to be varied, as the concentration of bromoalkane will be more or less the same throughout the run. Why? Come on, bromoalkane, what's the role of bromoalkane? It is also a reactant. So during the whole progress of the reaction, what will happen to the concentration of bromoalkane? It will inevitably drop, right? Because it's still a reactant. But once I change it to large excess, what will happen? What will be the change in extent of decrease? We become minimum, right? We become minimal so that we may see that the concentration of the bromoalkane nearly constant. Okay? You want to keep the concentration of bromoalkane nearly constant. So you may have get to know the word nearly constant, or you may to maintain the stable concentration of bromoalkane. You better not use the word stable, because stable in chemistry means something else. Chemically stable, right? Can you see the word? It gives a difference between the people who study chemistry to those, and also to those who doesn't study chemistry. So which category do you belong to? 張家榮。 Okay, so this is for ensure that to ensure that the rate of a reaction is affected by the concentration of hydroxide ion only, right? Okay, by the change in the concentration, by the change in concentration of hydroxide ion only. Okay, the change in rate is only affected by the change in concentration. Can you get my point? By doing so, now, so what is meant by that in mathematics? Originally, you write down rate is equal to K times bromo alkane concentration times hydroxide ion concentration to the respective order. Okay, if I use the bromo alkane in large excess, this one they will be roughly treated as a constant. Okay, such that this equation they will change it to K dash roughly equal to K dash, and to the concentration of hydroxide ions to the power y. After such, you can do a comparison more easily. Can you get my point? How? You are going to make this equal to constant and embed. It seems like this data can be merged with a K to form K dash. So that's why very often you are going to compare data. One keep it the same, the other keep it while you change the others. While the one to be keep it the same, you should make it in large excess. Do you understand? Zhang Gawen, do you understand? You're no longer a layman in chemistry. Agree? How about Chen Houhei? Calculate the initial rate for trial 3. Chen Houhei for trial 3. You just give me another question mark as an answer. So what is the answer? It's not maybe 0.000057 mole per billion per second. It's not maybe. Chen Jihin, can you tell? What is the initial rate of trial 3? Chen Jihin, are you here? So what is that? So how would you come up with the initial rate? It comes from the word, it comes from data time, right? If a time is 21 seconds. Here comes the initial rate 0.0057, and I will know it from the data 42 seconds. And here comes a slower rate by half, right? The time is double the rate. It will be slower 2 times, right? How about this? If the time is the same, of course, the initial rate is the same. So the answer, what is that? It is 0.000057 mole per dm cube per second. This is the answer. Okay, this is the answer. Do you understand? Okay. With reference to data, suggest the order of reaction with respect to hydroxide ion.
0 order.
0 order. Why? Why is it 0 order?
Because the concentration of the hydroxide ions does not affect the initial rate of the reaction.
Evidence, please. Evidence where?
Okay, comparing a trial 2 and trial 3.
So can you get the point? So everything starts from with reference to data. Can you see the word? So you are going to tell me by comparing 2 sets of data, you have to choose for me, first of all. 2 and 3, is it? Yeah, that's right. 2 and 3, while keeping this the same, and you are going to double the concentration of hydroxide ion, but the rate remains the same. Okay, so you are going to tell me like this. Can you get my point? So how would you write down in here? With reference to the data. Whenever you see the term with reference to the data, you should state that you should state that clearly. Okay? Can you get my point? So comparing data 2 and 3, trial 2 and 3, while keeping the concentration of bromoalkane the same, when the hydroxide ion concentration double, the rate remains the same. Which means that what? The concentration of hydroxide ion does not affect the reaction rate. So you may find that the order of reaction with respect to hydroxide ion concentration is zero order. Or you may say that it is the rate is independent to the concentration of hydroxide ion. Okay, it's up to you. It seems like what you are having in Form 1 SI, right? Scientific investigation. You are going to tell me the statement like this to relate to 2 factors. If there is no relationship, you still need to tell before you tell is 0 order. Do you understand? Do you understand?
Yes.
Yeah. And Chen Hongwan, are you here?
喺度。
Yeah, try. What are the values of X and Y respectively? So the order.
X is
order.
0. X is 1, Y is 0.
X is 1, first order, and this one is 0 order. 0 order I said it in D part, right? How about first order? How will you know it?
By comparing chart 1 and 2,
Yeah.
the initial rate doubled, and
When what? You know that
when
it is double, right?
yeah,
What changes?
when initial concentration of C4H9Br is doubled.
Yes, very good. Okay. Okay. Very good. Very good. Okay. Perfect. So you may find this is first order. XM0. How about F? If the units, you check the units. Tell me the units. Anyone who can help? Who did not answer? Who haven't yet answered? Xiu Junhei, Huang Jinpan, have you answered anything? Xiu Junhei. What is the unit? But wrong. So what is the unit? Xiu Junhei, you just keep on idling. Yes, it's per second. All of you have got it? Per second, the unit is per second. That's why the XYZ should be 0, 0, minus 1. Okay, 0, 0, minus 1. Do you understand? So the final questions before you end up the lecture today. Question 3. In a cold water bath with constant temperature, benzene diazonium chloride decomposes according to the equation below. And blah, 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 right? So you are going to measure the time taken to for the gas form is 50 cm cube, and you measure the time. You're going to plot 1 over T versus initial concentration of benzene diazonium chloride. Explain why initial rate is commonly used in the study of the kinetics of the reaction. Why we use the initial rate to study the chemical kinetics, but not some other rate? You use initial rate. Thomas.
係咪因為嗰個 concentration 係變化得未有咁多住，即係接近原本一開始擺落去嘅 concentration， 所以準呢個實驗。
Yeah, well, Wang Junho has got the answer, right? So you are going to make sure that at that moment you are going to find out the initial. You are going to relate to the initial concentration of reactor, right? So of course it is something about the known, whether or not the concentration they are known or not. Okay. Only by having something data which is known, we can do the relationship quantitatively. Okay. B. With reference to the graph. This time it's not with reference to data, with reference to the graph. Deduce the order of reaction with respect to benzene diazonium chloride.
From the graph, we can see that the dots can form a straight line that passes through the origin. Therefore, we can say that the order of reaction with respect to benzene diazonium chloride is the first order.
You just tell me it's a straight line plot. Any other information?
A straight line that passes through the origin.
Yes, passes through the origin. The straight line passing through the origin. So you need to tell me this all together. Okay? So remember, you are going to tell it's not just a straight line, but also this is the straight line passing through the origin before you tell it is in direct proportion. Okay, so you may find which. So you may see that the 1 over t, it is what? It is directly proportional to the concentration of C6H5 and 2Cl initial, right? But you have to relate to the rate first of all. How do you relate rate to 1 over t? How? The rate is also in direct proportional to 1 over t, right? So rate, it is directly proportional to C6H5 and 2Cl initial. Only by having this statement can you tell it is in direct proportional to. So it is first order. So the order of reaction with respect to C6H5 and 2Cl AQ is 1, first order. Do you understand? If you write down directly proportional, so you are going to, but you have to either write that in direct proportion or indirectly proportional to. 張家偉 in order to relate the two. You understand? You may either write it down. Now, how will you express this in written? How will you write down this one is written? Either in the mathematical way, you will see it on the left-hand side. How about in written? How? The rate is what? How will you write down this? The rate is agree? 張教授 suggests to write down directly proportional to. Agree? How about the others? I just boost your confidence by asking the others. If the others say yes, right? You will you feel happier? Yes, it's directly proportional to. Okay, get my point. C, why would be inappropriate to measure the time to collect larger volume of gas? So larger volume of the gas is related to the later stage of the reaction. Can anyone help? What is meant by the data? Too general, right? You may see that the data deviates from the initial rate. What is meant by the data? What data are you talking about? So you lack elaboration on that part. Come on, see. The longer the time, the larger difference between the actual. So first of all, what will be changed? The concentration, right? or actual concentration with the initial concentration? First of all, because of the difference between the initial concentration of reactant and actual concentration is different. Okay, and this is the cause, right? So what is the effect? The effect will change. It will be reflected in the rate. Okay, can you get my point? And so there will be the larger difference. Can you get my, what I mean? The larger difference between the measured reaction rate and the initial rate. So what I'm going to measure, it is in the initial rate. Initial concentration, that would you use this data to relate to the initial rate, okay, to make the difference. But when time proceeds to the later stage, that deviates from the initial concentration. They will turn to their own concentration, and of course, the measured reaction rate is will be straight away from the initial rate. They will be much different from the initial rate. So what does it mean by that? You are going the later stage that you are going to find, you are not going to find out the initial rate. How will you present it in terms of a graph? Right, the graph I would like to write down as volume of nitrogen versus time, and then we have got a graph here, right? So nitrogen is the product to be formed. They give a curve like this. So the point is about you're going to measure initial rate. So what can be done? So you're going to measure the very small volume of the gas, okay, and then mark it and try to mark it from 0 to 0 to that point. Here comes in 2 points. Form a straight line, you may get the rough data, the average rate at initial stage. You can roughly treat it as an initial rate. But if you start it from 100, 150, what will happen? Right, we still can get the data, but the data will much deviate from the original one. Can you see that? The larger the data for the volume, the much deviates, right? That slope will deviate from the initial rate. So what is initial rate? Initial rate is calculated by measuring the slope of the tangent at this time is equal to 0. So this is the initial rate, right? So what you just mentioned on this sentence is presented in this graph. Do you understand? Get không get? Last question. Besides the measuring volume of gas, what can be measured to follow the progress of reaction? The mass. Measure what would be the change in the mass? Remember, you are going to measure is an open system over time. So when reaction proceeds, the mass of a solution mixture drops. Okay? Any other method? Only this? Can you think of one more? pH? Agree? pH? Theoretically it is. What else? How about pressure? How about pressure? Yes, you may also use the pressure. You may also monitor the pressure. So once I write down pressure change, so you are going to do what? To measure the temperature and measure the gas pressure change in a container of fixed what? Volume. Okay? If the volume can be adjusted, sorry. Okay? You cannot get the answer. So measure the gas pressure change in the container of fixed volume. So during the whole progress of the reaction, because of the accumulation of nitrogen gas, the gas pressure increase. Do you understand? After today, what do you feel about today's lecture? Now, shall we take the attendance of all those guys before I leave? 0 to 4. 0 to 10. You just mark it 4 for me. All of you are here. 17 divided by get rid of me is just 16. Who is absent? Who just left? Pan Ziyi not here, right? You just left. Xiu Zhenhei here. I can do nothing but mark it again. Mark attendance again. Chen Jinghei here, right? Choi Dongfang. Pang Gahou. Pang Gahou, are you here?
Hello, hello.
Have you finished your work?
Not yet.
Wang Zhenhao. It's just little. Wang Zhenhao here, right? Chen Houhei. Zhang Gaowen. Yao Lang. Pan Nongdi here. Xiu Zhenhei here. Wang Yin. Okay. Pan Nongdi. Pan. Another Pan, right? Pan Ziyi just left. I don't know when. Is he supposed to join the DSC or is he leaving? I don't know. Zhang Gaowei, you better ask your friend, if he wants to leave. I don't want. I still don't know what happens to him. You just write down leave. He's going to leave. You mean? Zhang Gaowei, what do you mean by that statement? You better tell me. What's that? What happened to him? Now, for the others, take a look at the marks. Just two for Xiu Zhenhei. How can I have a quiz? Or you want to tell me that only by having a quiz would the score be higher? 108, 1166, 7.6550. Everything has been forgotten. F. You want to say for language to me, 潘老師? I mean, don't know. Let's do quiz. Okay, good. So I will have a quiz soon. Very, very soon. You remember my promise to all of you, weekly quiz before the UT comes. Okay, get prepared for that. See you guys on the Google Classroom. You are going to have a quiz. Okay, bye-bye.
拜拜，先生。
拜拜。